What if humans could visit other worlds and discover life beyond Earth? Not in some distant science fiction future, but within our lifetimes. Before we get started, check out the link in the description to download our ebook. Right now, as you watch this video, robotic explorers are crawling across alien landscapes, diving beneath ice sheets, and hunting for the building blocks of life on worlds we once only dreamed of reaching. For thousands of years, humans have gazed at the stars and wondered if we're alone. But today, we're not just wondering anymore. We're actively searching. From the red deserts of Mars to the hidden oceans of distant moons, we're closer than ever to answering one of humanity's most profound questions. Are we the only living beings in the universe? In this video, we're going to take you on a journey across our solar system and beyond, exploring the worlds where life might exist right now. We'll uncover the shocking discoveries scientists have made, the missions currently underway, and what the future holds for humanity's greatest adventure, the search for life beyond Earth. Let's start with the world we know best beyond our own, Mars. The red planet has captivated human imagination for centuries, and for good reason. Mars is the most Earth-like planet in our solar system, and it holds secrets that could rewrite everything we know about life in the universe. When you look at Mars today, you see a cold, barren desert. Temperatures average around minus 80 degrees Fahrenheit, and the atmosphere is less than 1% as thick as Earth's. But here's what makes Mars extraordinary. It wasn't always this way. Scientists have discovered overwhelming evidence that billions of years ago, Mars was warm, wet, and possibly teeming with life. Ancient river valleys carved into the landscape, dried-up lakebeds stretching for miles, minerals that can only form in the presence of water. The Curiosity and Perseverance rovers have even found organic molecules, the chemical building blocks of life preserved in Martian rocks. Here's the discovery that could change everything. In 2018, the Mars Express orbiter detected liquid water buried beneath the southern polar ice cap. Not frozen water, liquid water. Right now, on Mars, if there's liquid water, there could be life. Even today, hiding beneath the surface. We've sent an army of robots to explore Mars. From the first Viking landers in the 1970s to today's Perseverance rover, which is currently collecting samples that will eventually be returned to Earth. The Ingenuity helicopter proved we can fly in Mars's thin atmosphere, opening up entirely new ways to explore the planet. But rovers are just the beginning. Multiple space agencies are planning human missions to Mars in the 2030s and 2040s. NASA's Artemis program isn't just about returning to the moon, it's about preparing for Mars. SpaceX is developing starships specifically to carry humans to the red planet. The question isn't if humans will walk on Mars, but when. Now let's travel outward, past the asteroid belt, to Jupiter. This gas giant has 95 known moons, and some of them might harbor the best chance of finding alien life in our solar system. Meet Europa. From space, Europa looks like a cracked eggshell, its surface covered in a thick layer of ice crisscrossed with reddish-brown streaks. But scientists believe that beneath this frozen shell lies a global ocean of liquid water, possibly twice the volume of all of Earth's oceans combined. Think about that for a moment. A moon smaller than our own, orbiting Jupiter, with more water than our entire planet. And where there's water, there could be life. What makes Europa's ocean even more interesting is that it's kept liquid by tidal heating. As Europa orbits Jupiter, the giant planet's gravity squeezes and stretches the moon, generating heat through friction. This same process could create hydrothermal vents on Europa's ocean floor, just like the ones on Earth, where life thrives in complete darkness. Feeding on chemical energy rather than sunlight, scientists were shocked to find water vapor plumes erupting from Europa's surface, shooting hundreds of miles into space. These geysers give us a potential way to sample Europa's ocean without even landing on the surface. A spacecraft could simply fly through the plumes and analyze what's inside. NASA's Europa Clipper mission launched in 2024 and will arrive at Jupiter in 2030. It will perform nearly 50 flybys of Europa, mapping the ice shell, analyzing the plumes, and searching for the best landing sites for future missions. The European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, is also on its way to study Europa along with two other potentially habitable moons, Ganymede and Callisto. But Europa isn't the only moon hiding secrets. Saturn's moon, Enceladus, is even smaller than Europa, yet it too has a subsurface ocean and active geysers. The Cassini spacecraft flew through these plumes and detected organic molecules, salt, and even hydrogen gas, which could serve as food for microbial life. Then there's Titan, Saturn's largest moon, and one of the most bizarre worlds in the solar system. Titan has a thick atmosphere, lakes and rivers, and even rain. But instead of water, Titan's hydrological cycle runs on liquid methane and ethane. It's so cold that water ice is as hard as rock, while liquid hydrocarbons flow across the surface. Could life evolve based on completely different chemistry? Titan might hold the answer, and we're not limited to our solar system anymore. Astronomers have discovered over 5,000 exoplanets orbiting other stars, and many of them sit in the habitable zone, the region where temperatures allow liquid water to exist. Planets like Proxima Centauri b, just 4 light-years away, or the TRAPPIST-1 system with 7 Earth-sized worlds, 3 of them potentially habitable. The James Webb Space Telescope is analyzing the atmospheres of these distant worlds, searching for biosignatures, chemical signatures that could indicate life. So what exactly are scientists looking for? When we talk about searching for life, we're not necessarily looking for little green aliens. We're searching for microbes, single-celled organisms, the kind of life that dominated Earth for billions of years before complex life evolved. To understand what alien life might look like, scientists study extremophiles here on Earth. These are organisms that survive in conditions we once thought were completely hostile to life. Bacteria living in boiling hot springs, microbes thriving in Antarctic ice, life existing miles underground, feeding on radiation and chemicals rather than sunlight. If life can exist in these extreme environments on Earth, why not in the subsurface oceans of Europa or the methane lakes of Titan? Life as we know it requires 3 basic ingredients: liquid water, organic molecules, and an energy source. Many worlds in our solar system check these boxes. Mars has water, ice, and organic molecules. Europa and Enceladus have liquid water oceans and energy from tidal heating. Even Venus, despite its hellish surface, might have habitable conditions in its cloud layers. Scientists use sophisticated instruments to search for signs of life. Mass spectrometers analyze the chemical composition of rocks and atmospheres. Drills collect samples from beneath protective surfaces. Cameras and microscopes search for visual evidence. Future missions will carry even more advanced technology, including DNA sequencers that could identify alien genetic material if it exists. But exploring other worlds isn't easy. The distances alone are staggering. Mars is, at its closest, 34 million miles away. Europa orbits Jupiter, over 390 million miles from Earth. Even traveling at tens of thousands of miles per hour, spacecraft take years to reach their destinations. The Voyager probes, launched in 1977, are still traveling and have only just left our solar system. Radiation is another massive challenge. Beyond Earth's protective magnetic field, cosmic rays and solar radiation can damage both electronics and human tissue. Any crewed mission to Mars would expose astronauts to radiation levels hundreds of times higher than on Earth. Then there's the technology gap. We still don't have reliable ways to land heavy payloads on Mars, let alone drill through miles of ice on Europa or return samples from distant moons. Each mission requires decades of planning, billions of dollars, and technology that often doesn't exist yet when the mission is first proposed. And we must consider the ethical implications. What if we find life on another world? Do we have the right to disturb it? How do we prevent Earth microbes from contaminating pristine alien environments? NASA and other agencies follow strict planetary protection protocols, but as human exploration expands, these questions become increasingly urgent. Despite these challenges, the next few decades promise to be the most exciting in space exploration history. NASA's Artemis program aims to establish a permanent human presence on the Moon by the 2030s, serving as a testing ground for Mars technologies. Private companies like SpaceX, Blue Origin, and others are revolutionizing space travel with reusable rockets and ambitious colonization plans. For Mars, sample return missions are the next critical step. Perseverance Rover is currently collecting rock samples that will be retrieved by future missions and brought back to Earth for detailed analysis. This could happen as early as the 2030s. Human missions to Mars are being planned for the late 2030s or 2040s. These won't be quick visits. Astronauts would spend months traveling each way. With surface stays lasting a year or more, Initial missions would establish infrastructure, test life support systems, and search for resources like water ice that could sustain long-term habitation. Beyond Mars, missions to Europa and Enceladus are in development. Landing on these icy moons and drilling through to the oceans beneath represents one of the greatest technological challenges we've ever attempted. But it's also our best shot at finding extraterrestrial life in the near future. Why does all of this matter? Why spend billions of dollars and decades of effort exploring other worlds? Because the search for life beyond Earth is about more than just finding microbes on Mars or fish on Europa. It's about understanding our place in the cosmos. If we find life on another world, even simple microbial life, it would prove that life isn't unique to Earth. It would suggest that the universe might be teeming with living things, that we're part of something much larger than ourselves. And if we don't find life, that's equally profound. It would mean that life is rare, precious, and fragile. That Earth and everything on it represents something extraordinary that must be protected. Either way, we win. Either we discover we're not alone, or we discover how special we are. Both answers change everything. The exploration of other worlds represents humanity at its best. When we work together, pooling our knowledge and resources toward a common goal, there's no limit to what we can achieve. The robots rolling across Mars, the spacecraft flying toward distant moons, the telescopes peering at alien worlds, they're all part of humanity's greatest adventure. So the next time you look up at the night sky, remember, we're not just wondering what's out there anymore. We're going to find out. If you enjoyed this journey across the solar system, hit that like button and subscribe for more space exploration content. What world do you think we should explore next? Drop your thoughts in the comments below. Thanks for watching, and keep looking up.